This. Check voice, check voice. Yes.
Extra microphone.
No, it's supposed to hear.
Speaker also. No, mic also.
Oh, that. Oh, yeah. Yeah. Microphone. Okay. Yeah, yeah.
Ah, udah.
Udah,
Microphone.
yeah.
Yeah.
Okay.
You can say.
Check. Oh, hello, good afternoon. Really?
Because of the Wi-Fi signal. Can you okay?
Eddie, can you say something? I cannot hear you. Can you say something?
Test, test, test,
Yeah, it's very clear.
test,
Yeah, I
test,
can hear clearly.
test.
Kopi hitamnya ada yang
Good afternoon, everybody. We are still waiting for the all speakers to join the lines. So we'll be starting at around 10 minutes from now. I want to say hi first to Mr. Iling from PTKI. Pak Iling, are you there?
Siap Pak, baik Pak.
Oke, selamat siang Pak. Assalamualaikum.
Waalaikumsalam.
Ya, kita masih nunggu beberapa bicara yang lain ya Pak ya. Ini ada Mas Febri udah masuk. Mas Febri, selamat datang. Welcome to the.
Iya, Bapak. Terima kasih, Pak.
Kita ketemu lagi di langganan. Mungkin
Iya,
saya
Pak.
ini sudah yang ke-10 kali jadi moderatornya Pak Febri ini.
Terima kasih, Bapak. Mudah-mudahan tidak
Iya, iya.
bosan.
Iya. Sebentar ya Pak, ya sabar Pak ya,
Ya,
izin nunggu
bisa.
bicara yang lain. Ya, terima kasih Pak. Standby dulu Pak ya.
Baik, Pak.
Selamat siang Pak Hermanto. Selamat siang
Siang,
Pak Sudadi.
Pak. Siang. Enak gitu, Bu. Yang pembicara dulu mau masuk dulu, Pak. Sebentar ya.
Siap, siap Pak.
Standby dulu.
Ini juga ada yang saya kenal Pak Febri dari Inka, Mas Febri ini.
Jadi Bapak, kami murid Bapak dulu Pak
Eh,
di Elektri TV Pak.
iya, saya tuh berapa kali mau menghadap bos di Inka gak ketemu terus.
Oh, dengan siapa Pak? Mohon izin.
Waktu itu kan kita ada kerjaan dengan Trides dan Pak Slamet.
Oh,
Lihat tuh ke tempatnya Febri tuh.
oh siap
Kita
siap.
masuk tuh lagi ada kerjaan dengan Toya Denki.
J
Iya.
J J
Tapi
J.
bosnya lagi sibuk katanya. Ya, gak
Oh,
apa-apa lah. Yang penting udah tahu.
J Bapak,
Oke,
Insya Allah
senang ketemu
kita
lagi nih.
anu
Senang
lagi.
ketemu
J
lagi.
siap Bapak. J. Mohon izin.
Siap,
Assalamualaikum Pak
terima
Prof.
kasih. Waalaikumsalam.
Assalamualaikum Pak Prof. Iya, aduh. Mungkin kalau
Selamat siang,
kalau
Pak
murid
Iling.
mungkin masih kenal ke Bapak. Kalau Bapak udah banyak murid ya, masih
Iya, saya yang malu ini nggak banyak nggak hafal ini,
iya.
Pak Iling.
Mungkin Pak Prof
Wah,
baru gabung. Ya dulu eh,
siap.
saya seangkatan sama Pak Pak Purnomo, terus Pak ini
Oh
Pak.
iya,
Cuma saya di
93 Pak ya kalau gitu.
93 Pak. Cuma saya di listrik
Oh,
kebetulan.
J. Aduh, senang.
Iya
Nanti
Pak.
saya tanya Pak Purnomo punya nomor teleponnya Kang Iling lah. Saya biar bisa kontak
Ya,
kontak lagi.
iya Pak Prof.
Ini Pak, aki-aki.
Oh gitu.
AA-nya.
Ah, enggak Pak Prof.
Ya, enggak.
Sehat-sehat Pak. Ya.
Baik, kita, kita tunggu Pak.
No, it stays here.
Now, okay.
Check audio. No. Okay. Bandwidth is okay. Pakai HP aja. Oh, hotspot. Oh, oh. Itu sih reaksi hebat sekali. Ini pilih di sini. Asal network. Enggak, ini mau munculnya, muncul pilihannya. Saya keluar dulu deh. Sini, udah deket nih. Jam Check audio. Okay, good afternoon, everybody. Ladies and gentlemen.
Good afternoon.
Moderator, I would like to welcome you all to this webinar titled The Electrification of the Railway System in Indonesia. As you know, the webinar will be start soon, maybe after 5 minutes from now. First, I would like to check the presence of the speakers. Firstly, the chairman of MASCA is already here. I noticed before, Professor Yanuarsa and Professor Febri is also already here, and also Pak Iling. Those are all electrical engineering connections from Jalan Ganesha.
Dipekerjakan ke Rekap 5.
I'm the minority here because I'm the east part of the Ganesha.
Ada satu nggak
I'm
usah
from
ini nggak apa-apa ya. Yang masih
environmental
jatah ini.
engineering atau teknik penyehatan before.
Ya,
Saya angkatan 77 Prof Januar.
Ini paling yang ajuin
Bapak
saya satu
jauh.
Bapak tengah-tengah ke Pak
Ya, juniornya
Aditya ya?
Pak Ketum Chairman Maska Bapak Hermanto. First of all, I would
Udah
like to
ada
thank
ini.
you for
Ini
being
aja.
present here in this webinar. And I have to let you know that Mr. Alantandiono, the Director General of Railway, will be joining us soon after his meeting with the minister. He was supposed to be the first speaker giving the keynote speech in this webinar, but we have to change the rundown. Maybe he'll be showing up after some speakers here.
Jumat.
So,
Bener ya?
yes, we already late about 20 minutes.
Halangan hari kita.
Okay. Now, Pak Hermanto, are you ready now? Okay. To open this webinar, I would like to invite the chairman of MASCA, Mr. Dr. Hermanto Wiatmoko,
Jam
give his opening
15.15.
speech. Pak Hermanto, the screen is yours. Please.
Yeah, thank you very much, Pak. Yeah, thank you very much, Pak Krishna.
Yes, Pak Hermanto. Yes, please.
Yeah, okay, thank you very much, Pak. Yeah. Yeah, thank you very much, Pak Krishna, as a moderator. Good afternoon, all of the participants and also speaker. Distinguished speaker, Professor Yanuarsa Arun from ITB, Dr. Insinyur Febri, Febri Pandu Wijaya from PT Inka, Mr. Ing Suwoto from PDKI, and then also our international expert, Mr. Ralph Arli from Governor Consultant Germany, Mr. Eddie Kim from international expert, Maska from Korea, and also Mr. Dick Schneider from KW, and all of the our fellow regulators, operators, planners, national industry, and also academics, and all of the webinar participants who joined us online today. Let us offer our appreciation gratitude to Ahmed for his grace. We can get together in the strategic forum in a good health. On behalf of the MASCA, Railway Society, I would like to extend a warm welcome and my deepest gratitude for the active participation of all for ladies, gentlemen, and colleagues. Today, railway electrification is no longer just an option, but an absolute necessity and a key element in the modernization of our national transportation system. This step is crucial not only for increasing the capacity and operational efficiency, but also serves as a main pillar in supporting the transition toward a sustainable, low-emission transportation system. In Indonesia, we have successfully implemented the 1500 volt DC electrification system, which has proven highly effective in serving the high frequency commuter network in Greater Jakarta and also in Jogja Solo. However, as the direction of National Railway, development expand to improve intercity corridor and mainline network, new challenges emerged. 2026 system has no relevant because it offers higher energy efficiency, greater power capacity, and is ideal for medium and long distance operation. Our key challenge today is how to formulate an electrification strategy that is not fragmented. We must be capable of building an integrated national railway system in the future by taking into account versus the difference in service characteristics, for instance, commuter, intercity, and freight transport, investment efficiency and life cycle costs, and the third is interoperability of rolling stock and infrastructure. And then the last is a practical and seamless migration strategy from existing system forward a more optimal system. We do not need to start from start. We can learn from valuable lesson from our partner countries. Japan and South Korea, for instance, have successfully managed DC and also AC system in parallel. Similarly, European countries are currently moving to AC system standardization. Therefore, collaboration with international partners, technology experts, and financing institutions such as those present today become highly crucial for Indonesia. Through this webinar, Master hopes that this forum can serve as a productive venue for exchanging knowledge, experience, and best practice. We aim for several strategic output from today's discussion, including the strategic regarding the selection of the electrification system, policy direction for national system integration. This webinar is expected to become an important milestone in shaping the direction of the railway electrification policies in Indonesia that are technically and economically efficient as well as sustainable. I would like to express my highest appreciation to the entire committee, speakers, sponsors, and all parties that have helped to make this event a reality. By asking Bismillahirrahmanirrahim, I officially declare International with the theme toward an integrated railway education system in Indonesia for urban and mainland network officially open. Thank you very much. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Pak Hermanto, as the chairman of ASCA, for your opening speech. I took some notes from your speech. That the first is the electrification of the railway lines system is a must in this modern world under the umbrella of the Sustainable Development Goals, Sustainable Transportation System. And the main important thing in this matter is that we have to build a common understanding and a common principles for building the development of the electric railway system in Indonesia. As that, it is supposed to be continued with the presentation from the Director General, Pak Alan Chandiono. As I said before, he is still in the meeting with the Minister of Transportation. So we'll just move to the next session.
to our beloved professor from ITB, Pak Yanwar Saharuns, the main teachers of all the railway electric persons in Indonesia. Pak Harun, semua di sini adalah murid Bapak dalam soal elektrifikasi dan either they come from the electric engineering or not, but when they come to the electric system in Indonesia, in the railway system, semuanya jadi murid Bapak dan paling tidak pernah mengikuti apa seminar atau konferensi yang Bapak berikan. Pak Harun, with all respect, I am turning the screens now to you and entertain us with your presentations. The screen is now entirely yours. Please, Pak Harun.
Thank you, Chairman, Moderator, Pak Krishna Hamzah. Nice
Ya,
to meet
Pak.
you again.
Terima kasih. Iya, Pak.
Yeah. Okay. So, good afternoon, ladies and gentlemen. First of all, I would like to highly appreciate to the Maska Association, especially Pak Chairman, Pak Bambang Hermanto, and all other leaders of Maska. Thank you for opportunity and being invited as a speaker. Well, according to the request of the Maska committee, the topic of my presentation is technical comparison and energy efficiency of 1500 volt and 20 kV EC, certainly for railway electrification. Distinguished audience, so for this occasion, I invite one of my best college. Now he is also lecturer in ITV, and he was one of my best student, Dr. Tri Desmana Rahmilda, to collaborate with me in preparing paper for this afternoon webinar. Evidently,
Welcome,
he
Pak Tri
will be
Desmana
also
Rahmilda.
speaker with
Ya,
me.
ini
Sorry?
harapan kita di masa depan, Pak Tri Desmana
Ya,
Rahmilda.
ya, Pak Trismana.
Iya.
Thank you, Pak
Ya, silakan.
Pak
Oke,
Krishna.
thank you. Welcome.
So,
Okay.
briefly, please, as Maska has already my presentation, my PPT, please, or Pak Trides mana will be short.
Okay.
Please, Pak Trides,
Ya, Pak.
or by Maska. I don't know how does it work.
I think I share screen for the presentation.
Okay, thank you. The next slide. So this paper presented and prepared by me and Dr. Tri Desmana Rahmilda. Pak Tri Desmana, he is now lecturer in School of Electrical Engineering Informatik Bandung Institute of Technology, and me, I am as retired professor and now emeritus professor at Gunadarma University. Next slide, please. So we will discuss about 1500 kV DC system and 20 kV 50 Hz system. We have 4 subject for 1500 and also same 5 subject for 20 kV. Next slide, please. Yeah. So this is the short history that the DC is a long story and started from developed at the end of the 19th centuries or at beginning of 20th century. Commencing by Werner von Siemens, he shown the model of electrification in one exposition in Paris, in Paris, and following by Frank Sprague. It is for EC railway system starting from Hungary and finally France in 1983 success to change from 20 kV to 25 kV 50 hertz and become a proven reliability and accepted all the world. Next, please. Yes, we have for the railway electrification DC system, the KCI, KRL1, MRT, Jakarta, Jogja, Solo, 1500 volt DC, or maybe next, Surabaya, SRRL. Next, please. So this is the suburban characteristics of 1500 kV. We have a substance spacing around 2 up to 5 kilometer. The wire is thick, high current. The rabbit of source energy is less because it level 20, comparing in 150 kV. Yeah. Quaternary construction, you have the number and also the cost of traction substation for 1 megavolt ampere. Please. So this data we get from the book of Professor Baumgartner from the École Polytechnique de Lausanne, Switzerland. Yeah, this data. Yeah, maybe in Indonesia less, yeah, less or higher in this figure. I don't know exactly. Maybe the people from the minister can answer my question. Next, please. So this is the incoming input for the MRT Jakarta to supply 1.5 kV from 115 kV. And there is the network 30 kV to supply some of substation to produce 1200 volt EC and later become 1500 volt DC. Next slide, please. So this is the typical of rectifier using in parallel between three phase, yeah, and connected in parallel by IPT. The problem for this kind of connection is the average voltage is same, but the incident voltage is same. By this reason, we use IPT to eliminate the difference in instantaneous voltage. So we have in the center the negative voltage one to go to the negative feeder cubicle or the rail. Certainly, the rail will be floating. Yeah. Okay. Next. So the system has the strong one with the N1 minus one N-1 operation contingency, because if one fail, the other still can work, yeah, to support. But with the mode of with headway mode operation bigger than previously. Next. So this is the characteristic of 12 pulse rectifier using mostly in Indonesia. According to IEEE 519, there is still the harmonics not comply, but it could be eliminated by using a passive filter on AC side. This is the AC side. Next. Yeah. So for 20 kV AC system, example we get from WUS, yeah, we have 10 megawatt with 8 car per set. The substation spacing is around 40, 60 kilometer. Actually 40 kilometer, we have 4 in case of Jakarta Bandung. The wire is thin, yeah, less than DC system. The reliable source of energy is high, yeah. The incoming 150 kV is coming from two sources. This is the cost of catenary construction and MVE and one MVE traction substation we get from the book of Professor Baumgartner. Next, please. So this is illustration how we get the high voltage, the power from 1500 kV PLN is coming from the area Jakarta, PLN Jakarta, and also west of Java. Next, please. So we have to get attention. Some of island to stop island of 150 kV to supply the traction Asia traction station has the hydropower plant generator. So do the yeah. So next, do the due to unbalanced voltage because next please, yeah, next, yeah. So this is the configuration of the we have four traction substation. We have two among children we have the SSP sectioning post, and for one section we have two ETP, auto transformer post. So okay, for distance 142.3 kilometer. This is next please. This is the type of the transformer we use in the 25 kV Jakarta Bandung, single phase in Tegaluar, and the other one is VX type. Yeah. So if we look at the VX type, we can see that. Next slide, please. There is the current in the first phase B is not same with the phase A, phase 1. So the unbalanced current in the 150 kV system, which could contribute to unbalanced voltage, which ultimately give rise to negative sequence current. So the hydropower power plant in the island will consider sorry, will consider as double frequency, double or the other was 100 hertz. So it will create the overheating in the machine. It's not good if voltage and unbalance factor bigger than 1%. Next, please. So this is the formula from IEC, how to compute voltage unbalance factor. So next, please. This is the type of the feeding power system for direct power supply with only one return conductor, one multiply 20 kV. This is only for the speed up to 200 or 200 kilometer, and for the other power supply mode is the speed for the close to 350 kilometer, 250 up to 350. Next slide. So already, yeah. So this is my previous explanation. Next, please. So this is type of simple catenary using for the area direct feeding system. Yeah. So next one. So this is stage catenary in the area of high speed. Usually the simple catenary is ballastless, and the other one for the stage catenary is by using slab track. Yeah. In beton. Yeah. Next one. So I request to Pak Tri Desmana to continue my presentation. Please, Pak Tri Desmana.
Thank you, Professor Yanuarsa Harun, and thank you, Mr. Chairman, for the opportunity to continue the presentation from Professor Yanuarsa Okay, I continue with the comparison between the DC and AC railway systems according to the previous explanation from Professor Yanwarsa. You can see that for the DC system, okay, for the DC system, hello, can you hear my voice? Okay, hello. Okay, I continue. So for the DC system for 1,500 volt system, 1.5 kilovolt, it is suitable for the urban or transit. As for the AC system,
Please continue the presentations, but I just want to remind you that you actually have already crossed the border of the time.
oh,
Yeah, from number 3.
yeah,
Excuse me.
okay.
But before you continue, you actually the problem. The timeline will be 5 minutes. Thank you.
I didn't hear very well, Mr. Krishna talk.
But you have only 5 minutes left. Yeah.
Saya nggak bisa dengar tadi apa ya? Mohon maaf. Mungkin.
Me too. It's not clear. Pak Krishna, it's not clear what you said. It's not very clear. Please repeat what you said.
Yeah, but please just continue. I'll give you 5 minutes.
5 minutes.
Okay.
5 minutes. Okay. Okay, I will accelerate my presentation. So this is the comparison between the two systems, DC and AC. As you can see that for the DC system, in fact, it is more suitable for the urban application. As for the AC system, it is for the higher speed and longer distance. Okay. Is there any problem with my voice? Can I continue?
Your voice is very clear.
Very clear. Okay. Thank you very much.
Apa mereknya?
Okay.
Please more faster.
Faster. Okay.
Can you hear me?
I'm going to talk about. Okay, we are going to compare between the current amplitude between the DC system and the system if they are loaded with the same power. For example, 3 megawatt, the current in DC system will be 2000 ampere, and in the AC system will be only 120 ampere. It means that if we calculate the losses in the contact wire, we will have lower losses in the AC system, of course, because we use higher voltage. And then for the traction station, especially for the transformer in DC system, higher 12 pulse or maybe 18 pulse in the more complicated system. As for the AC system, we require the Scott transformer or V or VX single phase transformer with the objective to balance the three phase if because in AC system in the pantograph of the train will be connected only on the one phase of the catenary system, right? So to balance this unbalanced effect from the pantograph, we can use the Scott transformer or V or VX single phase transformer. And as for the regenerative braking in the DC, because normally we use diode-based rectifiers, it is not possible to do the regenerative braking. So in fact, if we want to do this regenerative braking, we should install the inverter to send power from the train to the utility. As for the AC system, because we use normally we use the PWM rectifiers, PWM inverters, PWM converter. So it is possible to do the bidirectional power flow between the train and the catenary system. And for the safety and installation, which is quite important because in Indonesia it is we know that for the 1,500 volt, the working safety distance or clearance, it is less compared to the 25 kilovolt. So for the 25 kilovolt, we will require more working safety clearance. The track must be segregated. It means that it is not disturbed by other activity, and it is not recommended for level crossing at grade with road or highway. And then for the losses evaluation, as we have heard from Professor Yanwarsa that from the DC system, the catenary wire, it is more thicker than the AC system. So the resistance should be less than the AC system, 0.08 ohm per kilometer. And for the AC system, it is 0.15 ohm per kilometer. But if we calculate the losses in the catenary wire, we can see that losses in the DC system is higher because we use less voltage of the system. So the losses will be higher than the AC system. As for the traction substation and the main transformer losses or the inverter of the traction motor, in fact, the efficiency is the same, mostly the same. We do not see any significant difference for the traction substation efficiency and the inverter of the motor traction. As the power factor, because the DC system use the rectifier, uncontrolled rectifier using the diode, so the power factor will be lower because when we use 12
Okay,
pulse
Pak Tri, I think the time is up.
it's up. Okay, I will go to a conclusion directly.
Okay.
Okay, I think we can go to conclusion directly. So for each DC and AC railway electrification, there are some advantages and disadvantages. Therefore, we should see wisely which one we are going to use. We are going to choose for the application in the field. And some aspect that we have to also consider is that between 25 kilovolt because
Tapi terkadang sih menurut
medium
saya
voltage.
itu agak hiperbola juga lah gitu kali ya.
So we have to consider that using 25 kilovolt, it is medium voltage and it is more dangerous compared to the 1,500 volt DC system. I think that's all for our presentation. Thank you very much. I give back to the moderator. Pak Krishna, I think that's all for our presentation. Hello? Can you hear my voice?
Pak Krishna, the time for us finished.
Yeah, I think the
Pak
time is up for you.
Yeah.
Can you hear my voice now?
Yes.
Yes, very well. Very good.
Yeah,
So
I
I
have
will
some
let
problem
I
with
will let
my-
may I
Okay.
say some word. There is a
Someone is speaking also. Yeah, see noise
there is
coming
a
from
big
the audio.
question now. In Surabaya soon will be electrified in the suburban area in the Gerbang Kertosusilo area. So the problem is will be chose AC or DC. The point is
Yeah.
this safety factor. We have 45 level crossing over there, and with the
Okay.
highest of the catenary trolley wire only 5.5 meter is very dangerous for 50 kW. But for the long
Yeah,
distance,
okay.
let's say from Lamongan and
Yeah.
Cikampek, around 700,
Mm.
it could be a hybrid at grade and elevated track. That's all. Thank you.
Okay.
Thank you, Pak.
Okay, thank you,
Prisman.
Prof. Janarsa and Dr. Tri, for your presentations. Yeah, I don't know if I'm having problem with my audio system here. It keep repeating the audio. I don't know what is happening now. I just have to move to the next presenter. That is Mr. Febri Panduwijaya from PT Inka. Pak Febri, can you hear me?
Ya, Pak Krisna.
Okay, please soon start your presentations. We are running out of time.
Oke, thank you Pak
Kita
Krisna.
sudah berkejaran waktu. Thank you very much.
Ya.
Please, screen time yours. Yeah.
Okay, thank you Pak Krisna, thank you Pak Irmanto as the opportunity for giving this or sharing this experience of PT Inka. So today I would like to present about the readiness of the national industry. This means PT Inka itself for AC and AC/DC rolling stock production. I am Febri Pranuwijaya from the Research and Development. So first, I would like to talk about the worldwide reference of AC and DC electrified railway system. This is the characteristic of a railway network in European country. This is an electrified railway line with alternating current or AC catenary system. From this figure, we can see that we can conclude that some of the network are AC 25 kV, some of them is AC 15 kV and other AC system, and also DC 3 kV and DC 1.5 kV. So the number of AC catenary system in European country is very dominant in this case, and mainly are used in northern and eastern side of Europe, although some of the countries in northern side apply only DC catenary system. And the rest of the European countries utilize both AC and DC catenary systems with different AC and DC voltage level. So in this case, the message is in one country they can they can mix the catenary system between AC and also DC with different voltage level according to the requirement of the operator itself. And then this is the characteristic of a railway network in Japan. We can also see here that in Japan they also have DC 1500 volt and also AC 25 kV and also 20 kV. In this case, for DC catenary system, the main point here is it is used for the backbone of a commuter line across the country. So the blue line here is DC 1500 volt, not AC 25 kV or AC 20 kV for the backbone of a commuter line in Japan. I don't know why, but maybe according to Prof. Yanuar Saharun, explanation just now that the level of safety is needs to be higher for AC system. So maybe in Japan they prefer to use a DC system instead of AC, even for the commuter line across the country. This is not only for one city or one area, small area, but it is across the country. And for AC system, we know that it is used mainly for high-speed train Shinkansen. And this is the example of Java Island Railway Network, the existing and planned. This is the presentation from PT KAI a few weeks ago in one of FGD. We know some of the planning to increase the electrification network in Java Island, especially. For example, in the SSRL in Surabaya Regional Railway Line. And the target from the PTKI, or this is from the government yet, from 9%, 622 kilometer in 2025 to 15% or 1,133 kilometer in 2030. We hope this electrification rate could be increased year by year. So because we are the rolling stock manufacturer, I would like to talk about the propulsion system. What is the difference between AC and DC catenary system? This is the DC catenary system propulsion system. We know that we have a 1500 overhead line. The current would be sent to the train itself through the pantograph or maybe through the third rail for 750 volt system. So we have a VFF inverter, induction motor, and set, and also the static inverter transformer to the auxiliary load. In the system, there is no traction transformer. So in the input side, there is no traction transformer. And the system could directly use the 750 or 1500 volt catenary supply. And this is a simplified electrical architecture. And this system is a very proven commuter technology and deployed worldwide, high operational availability and major maintenance ecosystem. And this is also lightweight because there is no traction transformer in the input side. And of course, improve the energy efficiency. And this is widely used also in Indonesia for the commuter line, both for Jabodetabek and also Jogja Solo, and including the LRT in Palembang and Jabodetabek. And this is the propulsion system for AC catenary system. The right side is same as the DC catenary system. We have inverter, static inverter, and so on. And the additional one is for the traction main transformer in the input side, because we use a AC catenary system, and also the PWM rectifier in order to provide the DC link for the VFF inverter and static inverter. And this is the option one, or the design one, which is mostly used in Europe and Chinese country. The DC link voltage is shared between VFF inverter and static inverter from the PWM rectifier. And there is another system which is mostly used in Japan. They use traction main transformer and also PWM rectifier. But for the DC link voltage for the static inverter is taken from the third winding of the traction main transformer. And the static inverter has its own PWM rectifier. And for the Shinkansen itself, there is also a little bit different. They do not use PWM rectifier, but they use the PWM rectifier and static inverter in one box, one system, and also use the third winding from the traction main transformer. So this is the two design for the AC catenary system difference. But of course, this system is not so difficult because it is also already applied worldwide. Yeah. So if PT Inka has opportunity, we can also manufacture the rolling stock with this kind of system, both for option 1 or option 2. And now this is the readiness and challenges for PT Inka. As you might know that Inka has a very extensive experience in manufacturing LRT, EMU, DEMU, and so on in Indonesia. And our footprint is more than 90% of rolling stock operating in Indonesia has been manufactured by our company. And we already manufacture for non-propelled railway rolling stock more than 6,000 units. And this is the self-propelled and locomotive for more than 650 units. We already manufacture some of EMUs, from maybe a long time ago, from 90 something, but we only mention the latest for project. This one is currently used in Jogja Solo, and also we have EMU for airport link from Manggarai to Bandara International Soekarno-Hatta, and also now we are manufacturing 16 trainset of new AMU and 2 trainset for retrofit EMU from PT KCI. Also we have LRT in Palembang and Jabodetabek, and also some of the DEMU. In this system, we use mainly 1500 volt DC for the DC link for EMU and DEMU. And for LRT, we use 750 volt. And in this case, we would like to say that we already manufacture various kind of system. So in order to apply AC catenary system is not a big issue for us. However, we have one challenge in order to how to say convince that we could manufacture the AC catenary system. It is the test track itself. Yeah. Currently in Madiun, we do not have a AC catenary system test track, or our facility for testing the AC propulsion system is not available in Madiun. But currently we have also factory in Banyuwangi, and even now we are still building the DC catenary system in this test track looping 3 kilometer in Banyuwangi. But later on, we would like to add up 25 kV 50 hertz overhead line, because we know that this is also important for us. We should increase our capability. We should increase our competency in order to grab the market in especially in Indonesia. So hopefully later on we could install this AC catenary system testing track in Banyuwangi. And this is the last slide from us. Yeah. This is also example of a Java Island railway map. We know that this blue line is a 1500 volt DC catenary system in Jabodetabek and also in Jogja Solo. And we have also 25 kV AC in Jakarta to Bandung for WUSH operating line. So in order to implement full electrified railway network, of course, we need some time. We need some time, and during the transition phase, maybe we need some special vehicle in order to support the interoperability across different overhead line. Maybe in Surabaya, SSRL will be 25 kV AC or 1500 volt DC. We don't know yet, but in such case, we could implement dual mode rolling stock technologies. We know that in the world there are some examples for dual mode technologies. First is Alstom Coradia Polyvalent in Europe. They apply dual mode multiple unit system. This is designed for suburban, regional, and intercity transit. They use both overhead line at 25 kV AC and 1500 volt DC in the same rolling stock, in the same system. And another example is Hitachi Class 800. This is a high-speed bi-mode multiple unit, which operates seamlessly between AC catenary system and onboard diesel generator at line speed. So this train doesn't need to stop in order to change the operation between the AC catenary system to diesel generator system on board. So this technology enabling uninterrupted long distance rail travel. So they have a dual mode in this case, 25 kV AC overhead line and 1500 DC onboard diesel generator. Even though this system is a little bit complicated here, but we confidence that this integration could also be done by PT Inka itself.
Pak Febri, can you hear me?
Yes, Pak Krishna.
You have 3 minutes left. Yeah.
Okay, yeah, maybe 1 minute more from us. So based on its experience, we can conclude that PT Inka is ready to develop for both AC catenary system as well as dual mode rolling stock technologies to support the development of railway system in Indonesia. So not only DC, but we could also develop AC propulsion rolling stock, and also AC-DC, and also AC diesel, and also DC diesel rolling stock. We also know that currently PT KAI is also seeking for new technologies for their long rolling stock in order to catch their vision to be a world-class rail operator. So thank you. This is all from us. Yeah, hopefully this could be discussed later. Thank you Pak Krisna. Terima kasih Bapak Ibu sekalian.
Okay, thank you very much, Pak Febri, for your presentations. I am having a big problem with my system now. I can hardly presentations, but I can conclude the last part of your presentation that it's a statement that basically INCA is just to any kind of electric railway system built in Indonesia in the infrastructure system. Is that, am I correct, Pak Febri?
Yeah, yeah. Thank you,
Yeah.
Pak.
So basically, as a manufacturer, you can always able to answer the demand from the market. Okay.
Yeah.
So
Thank you, Pak.
yeah, let's now move to the next presentations. It's from PTKI. Pak Iling, are you the one who's going to be giving the presentation?
Ya, terima kasih
Pak
Pak.
Iling,
Ya,
some
baik.
people hasn't known you very well yet. Please first introduce yourself to the audience and then enlighten them with the presentations. The screen is now yours, Pak Iling.
Oke, baik. Kok nggak bisa ya? Share screen ya?
Yeah, please, Pak Iling. We can hear you very clearly.
Oke.
You are still mute, Pak Iling. Pak Iling masih mute itu.
Udah bagus kok, udah bagus juga.
Oke, mohon maaf Pak Krisna ya. Mohon maaf saya baru sampaikan.
Ya, oke.
Oke.
Continue, Pak Iling. Ya.
Pak izin mungkin saya sampaikan bahasa Indonesia ya Pak ya. Gak apa-apa ya Pak?
Gak apa-apa, lanjut Pak. Silakan Pak.
Ya, baik.
Pak Dick Snyder soal di mastering bahasa Indonesia.
Oke. Next. Sebentar Pak, ini ada gangguan sebentar ya Pak ya. Saya ini dulu.
Oke, nggak apa-apa. Lanjut Pak, santai Pak. sambil Bapak perbaiki, I want to say hi to my old buddy, Mr. Snyder. Ya, oke. Silakan Pak Iling, continue your presentation. Ya.
Iya Pak, izin Pak Krisna, Bapak-Bapak semuanya, Pak Prof, dan yang hadir hari ini. Izin Pak, saya mewakili Pak Heru, Pak Direktur Sarana Prasarana, yang kebetulan ada kegiatan lain penting, jadi saya izin mewakili Pak. Oke, baik. Terkait dengan Operation Experience this Electrification, Urban Rail and Future Challenge. Oke, baik Pak. Jadi seperti yang tadi disampaikan Pak Prof bahwa elektrifikasi di Jabotabek ini sudah mulai dari tahun 1925 dan posisi saat ini dengan berkembangnya teknologi sudah ada banyak perluasan maupun modernisasi terkait dengan MU ataupun perluasan di jaringan elektrifikasi di Jabotabek, Pak. Untuk saat ini kami di PT KAI menggunakan tegangan 1500 yang saat ini kita pelihara dengan panjang kurang lebih 600 kilometer. Dengan penumpang per hari hampir 1 juta per hari. Oke. Ini ilustrasi dari peta elektrifikasi di kami, Pak. Jadi kami untuk wilayah di Jabodetabek saat ini terpasang dan Yogyakarta hampir terpasang 71 gardu traksi dengan panjang total 877 km ya untuk Jabodetabek dan wilayah Yogyakarta, Pak, Jogja Solo. Selanjutnya permasalahan di transportasi kami khususnya untuk di KAI, jadi adanya pertumbuhan penumpang di wilayah-wilayah urban untuk penopang seperti di Tanah Abang, Rangkas Bitung, Bekasi, Cikarang, Cikampek, Nambo, Manggarai, dan Bogor. Juga terkait dengan kebutuhan peningkatan kapasitas dan layanan stasiun yang saat ini tumbuh cukup besar. Adanya perubahan sistem persinyalan dari blok tertutup ke blok terbuka. Selanjutnya juga ada perubahan terkait dengan stand formasi KRL yang ada di Jabodetabek, Pak. Termasuk juga perubahan headway di Jabodetabek. Permasalahan yang kita hadapi saat ini terkait dengan saat ini untuk Jabodetabek ada beberapa koridor dengan masalah jarak gardu antar gardu traksi atau jarak gardu antar gardu traksi. Saat ini untuk beberapa lokasi di Jabodetabek khususnya untuk Tanah Abang sampai dengan Serpong, Rangkas Bitung ini cukup tertinggal, artinya kebutuhan akan layanan angkutan cukup tinggi, akan tetapi dari sisi penyediaan infrastruktur saat ini masih terbatas. Artinya di sini cukup apa ya, dari sisi kebutuhan daya cukup minim ya Pak. Sehingga kemarin dari teman-teman di DJKA maupun di kementerian sudah merencanakan terkait dengan pembangunan gardu traksi untuk menopang wilayah Tanah Abang, Rangkas Bitung. Terkait dengan isu drop tegangan tentunya dengan sistem DC jarak gardu menjadi cukup strategis karena dengan jarak gardu yang saat ini cukup panjang banyak terjadi drop tegangan di beberapa lokasi termasuk juga adanya kebutuhan atau trip atau shutdown ya dari beberapa koridor karena beban dari KRL yang saat ini berjalan di Jabodetabek. Karena adanya peningkatan terkait dengan layanan 12 stand formasi 12, tentunya kebutuhan untuk kapasitas gardu menjadi tinggi. Hal ini belum ditopang oleh pembangunan-pembangunan atau peningkatan terkait dengan gardu traksi. Selanjutnya, permasalahan tidak kalah penting terkait dengan kapasitas gardu traksi existing saat ini juga menjadi isu di beberapa lokasi, artinya dengan kebutuhan daya yang cukup besar, kita yang terbangun artinya masih masih rata-rata kapasitas di lintas Tanah Abang Rangkas Bitung di 3.000 kilowatt, artinya dengan jarak rata-rata di atas 5 kilometer untuk beberapa lokasi yang ada di wilayah sana. Terkait dengan permasalahan selanjutnya terkait dengan usia gardu traksi yang saat ini dibangun atau dipelihara di wilayah Jabodetabek, ada beberapa lokasi yang memang permasalahan dari lifetime atau kerja dari gardu traksi yang sudah melebihi umur pakai. Dan ini di beberapa kesempatan dari DJK juga telah melakukan peremajaan pembangunan gardu traksi di wilayah Jabodetabek. Lanjut, jadi terkait dengan pertumbuhan dari tahun ke tahun ternyata cukup signifikan. Artinya di tahun 2025 dari data KCI kita dapatkan di angka 7,1%. Artinya banyak peningkatan mulai dari tahun 2022 sampai dengan 2025. Capaian artinya dengan operasional saat ini banyak dengan pengurangan headway, peningkatan frekuensi perjalanan, peningkatan ketepatan waktu on time performance, dan peningkatan kapasitas jaringan khususnya di khususnya di traksi ya, elektrifikasi. Kebetulan untuk kami saat ini bagaimana dapat melayani kebutuhan di Jabodetabek, tentunya banyak hal yang kita lakukan saat ini, artinya dengan pemeliharaan aset yang kuat, beberapa beberapa metode perawatan sudah kita minta juga sudah disahkan oleh regulator, artinya dari pemerintah, untuk kebutuhan perawatan di preventif dan korektif. Terkait dengan integrasi operasional di mana kita ada LAA atau listrik atau overhead catenary dan sarana rolling stock persinyalan dan telekomunikasi. Terkait dengan sumber daya manusia saat ini di kami ada untuk Jabotabek saat ini ada 120 orang untuk perawatan di lintas sana dengan sertifikasi pelatihan dan berkelanjutan. Dan terkait dengan beberapa budaya keselamatan yang kami juga terapkan untuk meningkatkan performa di layanan operasional di Jabodetabek. Lanjut, kami sampaikan terkait dengan tantangan sekarang saat ini. Jadi kami juga tadi seperti yang disampaikan di awal ada beberapa kondisi terkait dengan masalah infrastruktur yang tua, kapasitas, dan performa lainnya. Sehingga kami juga terkait dengan hal ini terus melakukan perawatan terkait dengan pembaruan aset, artinya penggantian ataupun dengan usulan-usulan kami ke pemerintah untuk melakukan peremajaan-peremajaan pada infrastruktur di jaringan listrik di Jabodetabek dan Yogyakarta. Lanjut seperti tantangan tadi operasional untuk masa depan, tentunya dengan bertambahnya teknologi, permintaan tren saat ini membutuhkan artinya dengan tren permintaan saat ini, headway, frekuensi kereta yang lebih pendek, artinya butuh terkait dengan ekspektasi atas kehandalan untuk menjamin operasional di Jabotabek ya Pak. Untuk gangguan kami coba bagaimana mengurangi atau meminimalisir gangguan di wilayah di KRL ya, karena memang untuk kondisi di Jabotabek cukup strategis sehingga ada permasalahan sedikit ini cukup menyita perhatian masyarakat. Selanjutnya terkait dengan bagaimana kita ke depan, khususnya di saat ini terkait dengan perawatan di saat ini, bahwa untuk ke depan tentunya kita punya, saya sepakat artinya beberapa hal perlu ditingkatkan khususnya untuk kebutuhan urban atau jalur-jalur untuk elektrifikasi menggunakan AC. Tegangan 1500 tentunya lebih cocok untuk jarak-jarak pendek, sedangkan untuk elektrifikasi 25 kilovolt tentunya nanti untuk kebutuhan jarak jauh, sehingga elektrifikasi yang sekarang sepertinya cukup menjadi bagian dari urban atau transportasi, khususnya untuk di 25 kV bisa di hub atau disambungkan dari lokasi-lokasi akhir atau stasiun-stasiun besar yang menggunakan sistem DC sehingga bisa disambungkan ke lokasi-lokasi Jawa khususnya untuk intercity dengan menggunakan sistem AC. Selanjutnya terkait dengan artinya kami masih cukup perlu juga penyesuaian terkait dengan program-program di jangka pendek kami, jangka menengah dan jangka panjang. Artinya masih perlu juga terkait dengan kondisi existing saat ini, bagaimana perawatan ke depan lebih ke arah digitalisasi terkait dengan solusi-solusi kebutuhan elektrifikasi secara nasional. Itu mungkin dari saya jadi kesimpulan bahwa untuk kebutuhan 1500 kami kalau menurut kami masih cukup efektif untuk lokasi-lokasi di perkotaan yang memang jarak stasiunnya cukup pendek 2 sampai 3 kilometer. Harapan kami juga nanti akan menjadi bagian dari solusi transportasi jika ke depan akan menggunakan sistem AC. Itu tentunya di Jabotabek juga artinya butuh kehandalan operasional untuk peningkatan layanan transportasi. Termasuk juga mungkin kami juga di sini juga ada teman-teman dengan pemerintah di JKA, tantangan atas kebutuhan infrastruktur cukup penting khususnya wilayah Jabotabek atau mungkin expand ke wilayah di luar Jabotabek atau jaringan antar kota. Mungkin terima kasih dari saya Pak, izin mohon maaf atas kekurangannya. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Terima kasih Pak Ing. So, based on experience, jadi Bapak selama ini hanya punya pengalaman mengoperasikan 1500 volt DC ya Pak ya? Belum ada pengalaman untuk AC ya Pak? Kita belum pernah punya kan jaringannya pakai AC ya Pak?
Belum Pak,
Oke.
fokus untuk perawatan.
It's only, I think, kereta cepat ya yang pakai AC di Indonesia ya? Ya, oke. Baik. But we know globally the main standard of the railway electric system now is more on AC lines. That's what I heard from, and I read from many articles. And we need more explanation about this by the experience of the more advanced countries in the railway system, especially from German. We have here Meister Ulrich, Ralf Ulrich. Mr. Ralf, are you there?
Yes, I can hear you. Good afternoon, everybody.
Okay. I don't know how to say how are you in German. It's something like wie geht es Ihnen, mein Herr, something like that.
Okay.
I know.
Everything
Let's
is
just pretend
okay
it's
under the
correct. Okay.
circumstances.
Mr. Ari,
No problem.
take your time. Screens are all yours. Please entertain us with your experience about the
Yeah.
international railway electric system that is standard using the AC lines.
Yes,
Please.
I will try to share my screen for my explanation. Just a moment. Is it possible to see the pictures?
Yes, okay.
Okay. Then I will start the presentation. Just a moment. I cannot. So, okay. A short introduction of myself. I'm Ralf Alrich. I'm responsible in the Dornier consulting company for railway development. I have more as 35 years experience in railway development. We are not directly a designer in detailed points in the railway development. We work more in the field of network development, of master planning, under consideration of the technical requirements, and also under consideration of operational opportunities. So I will start my presentation also with a very short overview about the European electrification system. Everything what you have here on the screen is a mixture from a lot of different systems. The green lines and the red lines are AC systems, and the blue lines in principle DC. The development stages in Europe was very different. That started in the beginning of the 1900th century.
Ralph, I'm sorry.
Yes?
We cannot see your presentation.
Oh, you cannot see the
it's
presentation. Why?
we are seeing your slides, but not seeing the whole presentation.
Yeah, your slide is not moving.
The slide is not moving. Just a moment. Just a moment.
They're still in first page.
Maybe we are not in the presentation mode. Just a moment. I go back. It is better now.
Yes, it's changed now.
Yeah.
Okay, it's changed now.
It is moving now.
Then we have to use. Oh, sorry. Again. I will start again. So. So I will try again. So again. So you can see the screen now.
Yes, we can see, but you're not in presentation mode, but we can see slide.
Yeah. I know, I understand. I will try to start the presentation mode from begin. And you can see the changing now
Yes. Now it's
of the
good.
slides.
Yes.
Yeah, you have now the overview about the network in Europe. The green lines and the red lines are AC in different stages with 15 kilovolt and 25 kilovolt, and the blue ones are the DC system. The countries had different stages of development. In the first stage, beginning in the 19th, they started with DC. Only DC was available from the technical side. Later on, it developed the three-phase motors that you developed the electrification system in direction to AC. And as a result, we have now a mixture of a lot of different systems. And we cannot replace or remove one system and bring a new system. In Europe, we have only the option that we use multiple locomotives which can operate under the different systems. In Indonesia is a better situation. You have only DC at the moment, and the main part of your network is non-electrified. Therefore, you can decide what is the best solution. I have here also an example. I hope the changing of the slide was okay. This is a part from our capital in Berlin, and you have here in green the AC system, and the other ones are the DC system for city trains and for the public transport in Berlin. We call it Berlin S-Bahn. So that means we have also the situation that we have different systems for the public transport in the big cities, in the large cities, and for longer distance trains, we need AC because AC is, from our point of view, more efficient. And if you have a view in a long-term development of the railway network, is it the state-of-the-art solution at the moment? And I will avoid explain again the advantages and the disadvantages from AC and DC. I think that was point of discussion before. In principle, we have the same results. The option, the differences from both systems, I can go in principle to the conclusion. We can say DC is a very good system for commuter trains, trams, subways, and so on, for the public transport by railways in large cities and their periphery. The other one, the AC system, is for longer regional passenger transport, for more speed, for high speed, and also they supplied enough power for heavy freight trains and freight transport by the railways, and is in principle recommended as international standard in Europe for new electrified railway networks. If we go to Indonesia and looking here, our doing at the moment in Indonesia is a investigation in the scoping status. It's a very early status before we going in detailed design and so on. We looking for the electrification, stepwise electrification of two lines with priority. We have on the line Cikarang-Cikampek, and we have also the line Padalarang-Cicalengka. The current situation is that we have for Cikarang-Cikampek until Cikarang, the existing DC system as part of the transport system from Jakarta, and is absolutely understandable and reasonable that the influence of the capital of Indonesia have more periphery. You have more passenger travel for the city, and you need the extension of the system that you can move more passengers daily outside the city, inside and back to home, and so on. Therefore, is it in this point, from our point of view, recommendable and the best solution, the extension of the DC system until CCAMPEC, because the system is available. The extension for around 40 kilometers is in principle okay. We have more substations, that's clear, and is a little bit expensive. But otherwise, if we changing the system to AC in Cikarang, is it complicated? The station is complicated. We have not enough space from my point of view for a system changing. And I come in the next slides to our proposal. The other one, Padalarang to Sikalengga, have the background similar Jakarta, that the city system, the public transport in Bandung will be extended. We have also increasing of passenger volumes in the future, and also the requirements to increasing the public transport. But the point is, from our point of view, that for this line, for this section, are also 40 kilometers, extension with DC can be a problem. One point is you have then, if you started here with DC, you have then in principle a DC island for a long time. And you need then also the rolling stock and the technical requirements. We have here the situation that we have similar parallel, the high-speed line operated with AC, and the substations from this one are near Padalarang and also Bandung, between Bandung and Cicalengka. And we have in principle from the technical side the option to extend the substations. We need not more for this section, and started here as first also with AC system. Then when we go to the next slide, we can change in principle the systems in the station of Cikampek from direction from Jakarta. Cikampek is, from our point of view, we had a visit on site to the station, a very nice place for both systems, that we can change the systems in the station, because the station building is located in the middle of the tracks. And we have the option and enough space that we use one side for starting AC, and the other side as DC area, as terminal station for the public transport coming from Jakarta. We have then the option that the passengers change the trains, go to the longer distance trains, or later on, if we want to go directly from Jakarta in long distance trains to Surabaya or whatever, then is it possible use, in this case, multiple locomotives with both systems, or you have then later on, if enough space, that it needs a separate investigation, that you have then between Jakarta and Cikampek additional 2 tracks electrified with AC. But you have then the option, you have a full system. That's our idea, what we investigate at the moment. What is the best solution? We have here in the slide the capital. We have here Cikarang. The blue one is the existing DC system that can be, from our point of view, extended to Cikampek. In Cikampek, the next one is from the priority, the electrification between Padalarang and Cicalengka. From our point of view, is it very sensible to do it in the new system in AC. Then you can stepwise close the gap with AC, and step by step. That's at the moment a kind of investigation, which direction is the best one, and have the capacity to extend the system stepwise until Surabaya
Mr. Ali?
integrates the system.
Mr. Ali, just want to remind you that you have 3 minutes left.
Sorry,
You have 3 minutes left for your presentation.
Yeah, of course.
Yes, of course.
Yeah, that's
And I have to use...
that's in principle
Okay.
our proposal, and that can be developed. Very important, I will say, to finalize. We need also in our focus the long-term development of the whole network in Indonesia, and also the operational requirements, the increasing passenger volume in the next years, and there's only a question, how long is the view in the future? And therefore, is it maybe sensible to discuss such solutions like this? Yes, that was my discussion point for your webinar, and thank you for your attention.
Thank you very much, Mr. Ali. I have to run here and there because the problem of my audio system. Now I'm using the chairman's computer. So you see, the name is now Hermanto Wiatmoko, chairman. Anyway, thank you very much for being with us, Mr. Ali. I hope this is not just the end of our stories. Yeah, this is only the beginning. And I now, oh no, before I move to my old buddy, Mr. Snyder, I have to welcome my colleague first, Mr. Kim. Mr. Kim, are you there? Yeah, Mr. Kim, because he just sat next to me, we cannot talk together, otherwise it will be a feedback. So, Mr. Kim, please entertain the audience to, Mr. Director General will be coming at the last. I just got the news. Okay, Mr. Kim, you have the privilege to talk before the dirigent. Please take your time. Screen is now yours.
Okay. Can you see my screen share?
Yeah, it is working.
Okay. First of all, good afternoon, everybody. My name is Ed Kip. I'm the international expert for Masca. Today, I would like to share the Koreans' experience with the AC/DC dual voltage, the commuter train, the operation, which has been successfully used for many years in the Seoul metropolitan area. The Indonesian continues to expand both urban and the mainline electrified railways. Korea's experience may provide useful insight regarding the interoperability between the different electrification system. Okay, this is the state of the electrification railway in Korea. Korea is one of the highest railway electrification rate in Asia. Currently, approximately 78% of the national railway network is electrified. Okay. And out of the 5,340 kilometers of the railway lines, approximately, and 40 1,182 kilometers are already electrified. Especially in the Seoul metropolitan area, the commuter rail system covers approximately 1,400 kilometers. There are two electrification systems in use. For the around the 360 kilometer, we are using for the DC 1,500. The mainly is used for the urban subway and the light rail lines. About the 1,040 kilometers, use 25 kV AC. This is mainly under the commuter railways and the suburban extension and airport railways and New York Express, the commuter lines in the underground, and also the kind of some near the express commuter line by the PPP. Okay. So because the both system coexist within the same metropolitan area, dual voltage and can I say this is dual voltage and dual voltage, the train technology became the essential one, some commuter lines since the 1975. Okay, this is the one of the example, the experience. We call this one as the Seoul Metropolitan Line number 1. Line number 1 is the oldest and one of the busiest commuter railway lines in Korea. And the total route length is approximately the 218 kilometer with the 102 station. And the unique feature is this line is the use two different electrification system. For the 1,500 voltage DC, 7.8 kilometer underground section in the central Seoul, and on the remaining the 210.5 kilometer using the 25 kV AC. Instead of the forcing the passenger to transport trains at the boundary, Korea operate the dual voltage EMUs that can run on both systems. This enables direct through running service across the entire route, improving the passenger convenience and operational efficiency. Now, some people can think, what is the important how trains move from the AC to DC system or the DC to AC system? As you might know, a train cannot symmetrically connected to the AC and DC power because would create a serious electrical problem. Therefore, a special section called as the neutral section provided is the installed between the two power systems. In case of on line number 1, when the train approaches the transition, the area near Seoul Station or the Cheongnyang Station, and then the traction power is temporarily disconnected. Then the train, the coast, through a short unpowered section, as I already called as this is the neutral section, the length of 66 meters. These 66 meters already required by the Korean the regulation. During this time, all onboard equipment is automatically changes from the AC mode to the DC mode, or vice versa. Passenger may notice a brief dimming of the light, but the process is automatic and normally takes only a few seconds, means only 2 seconds or 3 seconds. This technology has been operating safely and reliably for many years since 1975 in Korea. Okay. And this is the kind of some explanation of our AC/DC dual voltage EMU. Line number 1 used the large fleet of the dual voltage commuter trains, around 120 train sets, consists of the approximately 1,200 car, means that the one train set, each train set consists of the 10 car train set in operation. This demonstrates the dual voltage technology is not experimental, but is already used on a very large scale in daily commuter service in Korea. Next. Okay, this is another sample. The more the simple the example, the reference and the experience in Korea, we call as this is Seoul Metropolitan Line number 4. This line runs across the metropolitan area from the Jinjeop in the north suburban side of the Seoul to Oido station in the suburban of the Seoul in the southwest side. Unlike the line number 1 that I explained you in the previous slides, the proportion of the DC and AC section is the more balanced than the line number 1. About the 45.3 kilometer use the 1,500 voltage DC, and about the 40.4 kilometer use the 25 kV AC. So for this, the 1,500 voltage DC, 45.3 kV all underground tunnel, and for the AC section is all the on ground or under the elevated bridge. So again, the dual voltage train allow the passengers to travel across the entire route without changing the trains. This demonstrates the kind of the flexibility of the dual voltage operation in integration different railway networks. Okay, this is the AC/DC, the dual voltage EMU are in the operation for the Seoul Metro line number 4. So line number 4 use the dual voltage train series operated by the both Seoul Metro and Korail 2 operators. The combined fleet consists of approximately total 560 cars. At this moment, for the Seoul Metro, they have the 260 cars, means the 26 train set. And in Korail, they have another 30 train set for this line number 4 operation. Okay, this is just some kind of the main circuit diagram for the AC/DC dual voltage EMU. Okay, the key component is the AC/DC changeover system. It is installed on the nearby pantograph. Okay. Okay, as you see that here, this is when the AC section, the AC 25 kV go to the pantograph and main circuit breaker, and the AC/DC change switch. Then this AC change switch to the supply the input power to the main transformer area, and this is going to the contactor, and this is going to the converter, DC 1,800 voltage, and this is going to the inverter for the traction motor. In case of DC 1,500 voltage, the pantograph and this is still going to the MCB first, and also go to the AC/DC. And then this is go directly to the line breaker and filter reactor and go to the inverter directly, not through the converter side. So therefore, the key item, key one is the AC/DC changeover switch, changeover the AC/DC changeover system. Although this system is the more complex than the single the voltage train, enable to seamless operation across mixed the electrification network. This kind of the main circuit can be the different based on the train design, but I would like to show to you some the example how the AC/DC, the dual voltage EMU are operated in Korea, which what kind of the main circuit diagram that you see. Okay. Next. Okay. Based on this kind of information, I would like to give you a short the price comparison between the DC, the 1,500 voltage EMU, and also AC and DC dual voltage EMU. For this comparison, I bring the kind of the official contract, the amount in the core rail side or the Seoul metropolitan side. Okay. First of all, the standard 1,500 VTC EMU cost is approximately Korean 1.34 billion per car. This is equivalent to the around the ideal 16 million. In case of the AC/DC, the dual voltage EMU, is that the cost is approximately Korean 1.7 billion. And this is the equivalent to around the ideal 20 million per car. This meaning is the dual voltage train are the approximately, we can say 25 or 30% more expensive than the conventional DC only the EMU trains. However, we should consider this additional investment can often be justified by first, eliminating the passenger transfers, reducing the operational complexity, and improving network integration, and also providing the greater flexibility for the future railway expansion. Okay. So, in conclusion, in my opinion, Korea's experience showed that the AC/DC dual voltage operation is the practical and the reliable solution for the integrating railway network with the different electrification systems. For metropolitan areas, such as in Indonesia, Jakarta, Bandung, Surabaya, where both the DC urban lines and AC suburban or the mainline railway coexisted. Dual voltage EMU can provide seamless passenger service and improve overall network efficiency. I hope this kind of the Korean experience may provide the useful reference for the future railway electrification development in Indonesia. Also, the electrification shall contain not only to build the traction substation and overhead catenary system. It should contain also to improve signaling, telecommunication, and station, and depot, and other the sectors. Therefore, it highly requires the detailed and the reliable feasibility study, basic engineering design, and detailed engineering design before the kind of the construction, the starting or the procurement. So thank you very much. Thank you very much for your kind attention. Thank you.
Thank you very much, Eddie Kim. Mr. Kim is the expert of Masca International issues. Again, I have to move here and there because my audio system is not yet comply with the system. Could you please end your presentation and close it? I'm still checking whether the Director General Alan is ready now to give the presentation before I move to the next presenter, our old buddy, Mr. Snyder. Mr. Snyder, please keep patience. Mr. Degen might be coming before you. And we have the honor to let him give the speech before Mr. Snyder. Anybody from the Director General of Railway that is operating the Pak Dirjen's audio and video system? Gimana? Pak Untung? Start now? Not yet? Okay. So, Mr. Snyder, Pak Dirjen is not ready yet. He wants to listen to your presentation first before he gives his conclusion. So, how are you? Are you now in Indonesia or in Frankfurt?
I am at home in the area of Frankfurt in Germany. No.
Okay, I missed the time we
No
went
worries.
around Frankfurt. I hope we'll do it again later
Very
soon.
soon.
Okay,
Very
very
soon.
beautiful city, Frankfurt. Okay, I don't need to introduce you anymore to the Indonesians here because most of the audience is known you very well. Please, your title is Green Financing and Investment Models for Railway Electrification. I think you have started with Surabaya and will be going further to the other cities of Indonesia. Take your time. The screen is now yours.
Thank you so much, Pak Krishna. Good to see you all. Good to hear from all the different participants here, from the presenters. I think we have a very diversified field of discussion. It's highly interesting to hear different opinions, and the only question is now who pays for all this. Perhaps it's just as electrifying as 25 kV AC or 1500 DC to talk about the money matters. I'm not going to go very deep into the matter. Just want to give you a quick run through with regards to the instruments, to the means of financing electrification. Actually, you can expand this into railway systems in a broader context, but let's focus on electrification here and today. The word green in the title slide is certainly an important thing, because one of the key elements of electrification is actually to get rid of diesel. And to convert to a more energy efficient and sustainable means of powering our trains, alongside the fact that we are achieving capacity increases and so on with an electrified railway. So let me just give you a quick run into the affairs here. I've summarized a couple of means of financing railways in general. What I have to say first is we are not talking about a single kind of financing. We're usually in this kind of environment talking about a combination of instruments and sources. So we're not talking just about using APBN or concessional loans or PPP or. We're usually combining instruments of financing this kind of large size infrastructure developments. So here you see an overview of 7 means or 7 categories that you can find to support the financial side of investments. I'm breaking this down a little bit further. That is basically for you to read through. We start with the, let's say, more common and more conventional means like public budget financing, debt financing with loans, going then a little bit more into the adventurous areas which are not as established, like PPPs, like SPV structures. And we're ending up in the bottom of this slide with more innovative instruments that come from the green sustainability linked loans. Energy as a service is pretty far off what we can actually realize in Indonesia. Infrastructure as a service, similar story. On-site renewables, storage financing, I think we are not there yet, but these are means that are used globally to support the electrification in general, on the back of a general drive to decarbonization of transportation systems and the transportation services. So looking into a little bit more detail would mean to break this down. On the public side, we have the common things, budget financing. I've added here the regional and local government contributions, especially for commuter services, for MRTs and so on. We see this in Jakarta for the MRT, where DKI and the central government have worked together and are working together to finance the MRT. There's a bit of a speciality, but certainly the municipalities, the provinces, with their interest in these commuter and urban services, are bound to contribute in some way into financing this stuff as well. We go further into another pretty common area, debt financing, loans in the first place, sovereign, sub-sovereign loans to the state from national development banks like KfW, from the MDBs, the IFIs, through export credit agencies. If there's import involved, the advantage is obviously long tenors, grace periods, subsidized sometimes, and here we come already with a combination to something I'm going to mention later, subsidized interest rates with climate links. You can go further on the right on this slide where corporate loans come into place. It would primarily, from my today's perspective, affect PTKI with regards to acquiring rolling stock. I mean, it's part of the electrification to have electric rolling stock. That obviously means that also needs to be financed. That's where corporate loans may come into play. And of course, you can go further into the financial markets through issuing bonds that could be either done by institutions like PTKI. They are issuing their own bonds. It could also be government bonds, government green bonds that are put out into the market to acquire capital access on a green back through bonds. That has been an issue of the MOT in previous times. Has always been an idea, and certainly is a good idea, with risks attached, especially with currencies if you go into international markets. Further down the lane, concessional loans and blended finance. And I think here we have probably the key to electrification financing. We are, due to the green impact or to the environmental aspect of the whole equation, we are able to obtain loans below market rates, below market terms, with long tenors, in combination with commercial finance possibly, but sources are climate funds like the Green Climate Fund, like international climate windows of MDBs, energy transition funds like the JETP, which is being implemented in Asia. This is basically to make the entire package of bankability of a large investment adventure more feasible, more bankable, and make it more bearable for the looking at the financial constraints of a government like in Indonesia. The middle column here talks about result-based and performance-linked finance, which is an interesting subject on two perspectives. Number one, a lot of the MDBs, including KfW as a national organization, we're looking at the sustainability of investments, the environmental impacts of investments. So very often we find that loans are preferably given out to projects, to interventions that are environmentally positive, that are supporting sustainable developments. So we are linking sort of KPIs, indicators from the sustainability and from the environmental side into the financing or making it conditions to providing finance. In a similar way, you can also say there are grants in the market, there are bonds in the market which are explicitly marked as green, and they're working with indicators. And basically, the point is that these grants, these financial means are being provided based on the performance of a project, of the intervention, of the electrification, how many kilometers, how much CO2 emissions saved, and so on and so forth. They're linked to each other. This can be interpreted as results of the intervention, and based on the results, either discounts are being provided or certain grant funds are being freed up and can then support the overall investment, the overall capex. On the right-hand side here, you see the issue of carbon pricing, which is certainly something that can be taken into consideration, but is not today's and tomorrow's issue in Indonesia, from my perspective. Here we have a slide which I'm not going to spend much time on because I think we are too far off using PPP or SPV structures, considering the regulatory framework that we currently see in Indonesia. But of course, these are possibilities if regulatory frameworks are being adjusted in larger scale that could be used in the future when second and third and fourth phases of electrification programs are being implemented. As I said, the precondition, the pretext is that the regulatory framework, that the institutional framework is in place to implement these kind of structures. And that, of course, opens financing structures that, or access to financing structures which are different from what we see today. For a few small issues that support financing in the first place or relate to financing are the track access charges. That's where the operator comes into play. The same story goes for the traction energy tariffs and so on. And of course, you could theoretically also earmark sort of surcharges on ticket prices, on transport prices for the environmental. So let's say you're putting a 1% charge on every ticket to support the electrification, and dedicate this 1% of every income that you have from revenues into the financing of electrification projects. It's a bit far off because any price increase obviously triggers a public reaction, which is not necessarily positive. So I'm not going to ride this horse for too long. I think this is something we don't need to talk about at this stage. More interesting, investment grants. I think this is a pool of funds that could be tapped, provided that we find sources either nationally or regionally or globally, sources of investment grants that could become available. We are aware of large grants from the US, from the UK to Indonesia in the transport sector, which at least have been earmarked. And such programs could, for example, be used for financing electrification. Such investment grants are obviously bound to performance indicators, and the fulfillment of such performance indicators. If the targets are met, then grants can be paid out. You could also interpret investment grants as something that is given by the government of Indonesia to the railway or to the MOT, provided that performance of the electrification program is positive, that certain amounts of funds would not need to be repaid by the MOT to the central government, to the Ministry of Finance, provided that performance is in place. It's a matter of interpretation. The important thing is what I said in the beginning. We are combining the various instruments. We are not just riding on one horse. We are having a big bouquet of instruments at hand here. And I'm coming in a moment to those instruments that are more likely to apply in Indonesia at this stage for the program that we've got in mind. Here we have a quick overview of emerging innovative instruments that I mentioned in the beginning, the green and sustainability linked loans, which obviously have to go alongside the commercial, concessional and debt financing instruments. We have energy as a service, infrastructure as a service. I think this is something that needs to be thought through at some point with the agencies involved. This is nothing that we can do today or tomorrow because the setup, the framework for it is not in place. The same goes with storage financing, renewables, and so on and so forth. I think we're simply not there yet. But the ideas have to be on the screen because we are not just looking into a program for the next 3, 4, 5 years. We are looking into a long-term development. As we saw it on the screen earlier, a step-by-step implementation of railway electrification across the entire island of Java, at least, not to forget Sumatra, not to forget the other islands, is at hand. So we're talking about a program of 15 to 20 years, perhaps longer. And this is where these kind of arrangements could well come into play when the time is right for it. So what I've done here now is what can we do in current terms in Indonesia? I think the applicable and available instruments are the obvious ones: central government, sovereign, sub-sovereign loans, corporate loans with regards to KI for rolling stock, for example. Bonds have been issued, perhaps no green bond and no bond specifically for the electrification, but it is definitely a tool that the Ministry of Finance is fully aware of and can handle. We have the issues of concessional loans, blended finance. There is nothing new to it. Investment grants where applicable. Now look into the middle column here. There is 2 elements that should be moving into the left-hand corner. There is the result-based and performance-linked finance, which by its mechanisms actually can be implemented. And where the hurdles to get them into the, let's say, conventional financing would be rather low. And the same goes for green and sustainability linked loans, which is more a mechanical problem than a regulatory problem. I left PPP and project finance in the center here because I see them coming up at some point. But as I said earlier, that needs regulatory, institutional adaptations, changes that are not going to be done overnight. When I come to the next slide now, you will see that these 2 green arrows that I marked here are basically can be found in a kind of investment model for railway electrification in Indonesia that could be in the short run implemented. I tried to take the instruments and allocate the places where these instruments could apply to. central government budget primarily into land acquisition, resettlement, compensation. I think this is the core issue of government budgets, pure budget matters. As we see it in Surabaya, these are the things that are being paid straight from MOT budget in that case in Surabaya, or through APBN means. Then comes the whole set of loan arrangement, including concessional loans and blended finance, which is obviously the main source for covering the capital expenditure and for covering the debt services that will follow. We want to, and we would wish to see more result-based and performance-linked finance in this whole thing. We have here the link to green and sustainability loans that actually there should be one box, because there should be green result and sustainability performance. And perhaps we can merge these two boxes somehow into one thing, which would offer us the possibility of either interest reductions or more grant funds that could be used to finance electrification over time. In the bottom of this chart, you see the bond issuance as a tool that is readily available to access capital. And we see corporate loans, where I said earlier, these are basically funds that would come to railway companies, to the operators especially, and should primarily be focused on procuring rolling stock. I think they're just part of the story. Yeah. What I do not see is that major corporations, private corporations, or even SOEs start investing directly into the electrification. This is something we do not see. It remains a task at government level to implement such a possible program. Now, I mentioned the word program a couple of times already. The obvious thing is every country is different. We see here in Indonesia.
Mr. Schneider, you got 2 minutes left, I think.
Okay, I'm almost there. Thank you.
Okay.
What we need to, or what we want to see, is a balanced mix of public budget, debt financing, result-based financing is perhaps at this point in time the most suitable solution here in Indonesia. Concessional loans are basically available. Result-based financing is available in principle. There's a couple of things that need to be cleared up in terms of understanding what result-based finance means. Important here is that especially the result-based finance can comprise and should comprise and perhaps must comprise sustainability and green financing elements. We have a pretty visible drive in Indonesia towards decarbonization of public transportation, of transportation in general. There is actually the trigger for incentives that must be established to implement electrification, to electrify transportation. The incentives should be done through performance-related, performance-linked grants, interest rate discounts. SPV, PPP are not an issue right now. And my closing line is basically a suggestion. We should see that we establish a strategic, politically sanctioned railway electrification program implemented by the MOT as the infrastructure owner at this point, and financed as a program. So we're not stopping at sort of a 5 years pattern, but we're running into a program that operates over the next 10, 15, 20 years. And along with this program, it is then also possible to adjust the financing instruments and sources over time. So we're not getting stuck with public budget, with debt and results financing, result-based financing. We are actually leaving the door open for alternative, for new financing instruments over time. But we need to start somewhere, and this is the top of this slide. At this point, public budget, debt financing, results-based financing may perhaps be most suitable. I put an example into this slide deck for a result-based financing idea. For those who are interested, I shall share this PowerPoint document with everybody, so you can have a look at it. It would go too far to go into this example now, but it gives you an idea what result-based financing means, what performance-based financing means, and what is actually, it actually shows us something that is possible to implement in the Indonesian context for railway electrification within a rather short period of time. So thank you very much for listening, for your attention. I hope it contributed a little bit to the overall discussion, which from a technical perspective, I find highly interesting. And if that closes out the issues here, then perhaps it's a good time for the Director General to have a few words and reflect on what has been said. Thank you very much.
Okay, thank you very much, Mrs. Schneider. I'm very happy actually to take notes from your presentations, especially regarding the applicable and available options of green financing of railway development in Indonesia, some based on your experience and of your knowledge about being involved in some Indonesian railway project developments. And success for you, for the KFW. Please stay just with us for the next future, because as you said, talking about the development of railway is not something lasting for 1 or 2 years. It's we are talking about decades or maybe more time to be cooperated together. So yeah, your presentations has touched the need for us to finance not just the OPEX, but also the CAPEX of the railway development, and your readiness to help us with those problems. And now, like you said, it's time for us to listen to the speech from Mr. Director General, Mr. Alan Tandiono. Pak Dirjen, are you there already?
Yes, Pak Krishna.
Hi, how are you?
Thank
Dirjen,
you.
long time to see you.
Would like to wish
I'm
you
very glad to see you again
happy
here.
birthday also.
Okay, so I will not prolong my introductions. Just take your time, entertain your audience. You're the highest rank of the Indonesian railway policy now in the Ministry of Transportation. Take your time, Pak Dirjen. The streets entirely yours. Thank you.
Thank you, Pak
Please.
Krishna. Happy birthday to you. All the
Oh,
best
thank you very much
to you and
for
family.
remember that.
Happy to see many familiar faces.
Yeah.
Good afternoon and warm greetings to all of you, distinguished guests, host, Chairman of Maska, Pak Hermanto, yang kami hormati. Pak, terima kasih sudah mengundang. Distinguished guests I can see coming from KI, from Inka, from Donier, from KFW, just now Pak Dirk. I was listening to your presentation. Thank you, Pak Dirk. We also have international expert of Maska, Pak Eddie Kim, my friend from the High Speed Railway Project, Prof. Yanwarsha Harun. Good to see you again, Pak. Ladies and gentlemen, thank you
Nice to
once
meet you, sir.
again. Yeah, it is an honor for me to deliver this keynote address on policy and roadmap for national railway electrification in Indonesia. First of all, I would like to apologize. I was supposed to kickstart the webinar, but I was called by the Minister of Transport. Therefore, I asked the committee to arrange my keynote at the closing, before the final closing, of course, by the chairman of Maska, Pak Hermanto. I would like to express my sincere appreciation to the Indonesian Railway Society, Maska, for organizing this important forum, which brings together regulator, operators, industry leaders, academics, and also international experts to exchange perspective on the future of railway electrification in Indonesia. Forum like this comes at a crucial time when we talk about geopolitical tension, rising fuel prices, energy scarcity. I think is very appropriate and very relevant. As Indonesia continues to expand its urban and intercity railway networks, electrification has become a strategic pathway towards a more efficient, integrated, sustainable, and a more resilient railway system. The challenge before us is not whether electrification should be pursued, but how we can develop an electrification strategy that is future-oriented, interoperable, and aligned with our long-term national transportation goals. Ladies and gentlemen, aligned with the National Long-Term Development Plan, RPJPN 2025 to 2045, and the National Railway Master Plan, railway electrification is being developed to support an integrated, low-emission, efficient, and sustainable transportation system. The government of Indonesia views railway electrification as an integral part of the broader transformation of the national transportation sector. Its primary objective are to enhance the capacity and quality of railway services, support the national energy transition and low carbon development agenda, and last but not least, strengthen Indonesia's economic competitiveness. Distinguished participants, in formulating the National Railway Electrification Roadmap, the government takes into account several strategic considerations, including the characteristics of railway services, long-term investment efficiency, system interoperability, and the transition strategy from the existing system towards a more optimal and integrated network. Equally important are efforts to strengthen domestic industries and develop highly skilled human resource capable of supporting future railway technologies. I hope not only INCA is present today, I hope LAN, LRS is also present. Ladies and gentlemen, the government also recognizes that the transition toward a more integrated railway electrification system cannot be achieved overnight. Therefore, the national roadmap must adopt a realistic and phased approach. Priority will be given to electrification projects within metropolitan corridors while carefully managing the existing electrification system that continues to operate effectively today. At the same time, preparation must be made for the development of future railway corridors that are aligned with the long-term national transportation needs. Experiences from countries with more advanced urban rail systems demonstrate that multi-electrification system can be managed effectively when supported by comprehensive long-term planning. Just now, Pak Krishna mentioned it's not a 1 to 2 years thing. Require long-term planning. Clear national standards for new railway networks and the development of interoperable rolling stock and railway technologies. This is precisely why today's forum is so important. Discussions on the comparative advantage of the different types of electrification systems, the readiness of domestic industries to adapt, to our needs, operational experiences, rolling stock interoperability, as well as green financing opportunities mentioned by Pak Dirk from KfW, will provide valuable insights for shaping Indonesia's future railway electrification policies. Ladies and gentlemen, I sincerely hope that this webinar had generated strategic recommendations regarding our future direction of National Railway Electrification System, strategies for integrating urban railway networks with mainline railway corridors, the strengthening of domestic industries and technological capabilities, sustainable financing models, and practical, realistic implementation pathway towards a modern and integrated national railway system. Ultimately, our objective is not merely to build electrified railway infrastructure. Our goal is to lay the foundation for a railway system that serves as the backbone of national mobility, supports economic growth, and contributes to a more sustainable and more resilient development. With strong collaboration among government institutions, railway operators, industry partners, the schools, and international stakeholders, I'm confident that Indonesia will be able to realize this vision. The decisions, the discussions we make today regarding railway electrification will not only determine how our trains operate in the future, but also how the future generations of Indonesians connect, move, and prosper in a more sustainable and a more resilient society. Thank you for your kind attention. I hope this webinar was useful for all of us, and I look forward to more fruitful exchanges of ideas after this webinar that will eventually contribute to the future of railway electrification in Indonesia. And we all hope that it will be a successful one. Thank you very much, and I return the forum to you, Pak Krishna. Thank you. Thank you, Pak. Pak Krishna, Pak Hermanto. I think they may have some problems. Connection problems from Maska.
No problem.
I can see Pak Arif also from MRT. Hi, Pak Arif.
Hi, Pak Alan. How are
Yeah,
you?
I'm good. Panitia.
I'm sorry, Pak Dijen. Yeah, my connection was gone, so I have to move Pak Edi Kim's place. But it's good that you are able to create Pak Arif Rahmat, our called buddy here. Pak Arif, apa kabar Pak Arif?
Baik, Pak.
Okay, yeah, the connection is very bad, you know. Thank you for being here, Pak Arif. Yeah. Okay, ladies and gentlemen, we have listened to the speech from Pak Dirjen talking about the expectations, the hope for the railway development in Indonesia, the roadmap for the electrification. Pak Dirjen, we are from Maska, very happy with your presentations. Like it is said by the Liverpool fan, you'll never walk alone. Maska will always be supporting you. You know,
I'm an Arsenal fan.
Although Liverpool is not a champion.
We are the champion. We are.
Okay,
I'm an
now,
Arsenal fan.
yeah. Yeah. Oh, okay. Good. We are supposed to have a question and answer session today, but the time is very much up. So, yeah, we need time for certificate award. for the speakers, Pak Dirjen. Please stay for a moment. Pak Ibnu, are you ready for the presentation of the award of the certificate? Please take your screen and post the certificate for the speaker. Oh, Pak Ahmad. Okay, this one is for Pak Dirjen. Pak Dirjen, I hope you like it, this design. Okay, we'll send it to you soon to your office.
Thank you, Pak.
Okay, the next certificate, will be awarded to the speaker. Pak Ahmad, lanjut Pak Ahmad. Our mentors, Pak Yanuar Saharun, Pak Dirjen. Ini mentor semua orang, Pak. Ya, tadi ada juga penerusnya Pak Trides tadi. But ya, Pak Yanuar Saharun, thank you very much, Prof. Yang sehat ya, Prof. Jangan bosan untuk
terima kasih.
memberi penyerahan pada kita
Matur nuwun.
semua.
Thank you.
Iya. Kemudian the next certificate will be awarded to Pak Febri. Wah, ini juga teman kita ya.
Terima kasih, Pak.
Lama Pak Dirjen. Ya, ini jangkar kita di PT Inka yang mudah-mudahan terus berkarya, terus mengembangkan inovasi-inovasinya, membantu Pak Dirjen untuk mengembangkan railway system di Indonesia.
Siapa?
Pak Febri ya, jangan kemana-mana Pak, tapi jadi Inka ya Pak ya.
Siap. Iya, Pak.
I heard you got so many offer from Japan ya. Janganlah Pak, di Indonesia ya masih butuh Bapak. Okay. And then the next certificate given to Pak Iling Suwoto. Pak Iling, apa kabar Pak? Terima kasih sudah bergabung ya Pak ya. Mewakili Pak Direktur. Ini juga Electro Connection. Gengnya Pak Dega, Pak Iling, Pak siapa lagi itu di sana? Termasuk Pak Dirut ya. Semuanya murid-muridnya Pak Prof Januarsa dan teman-temannya Pak Trides ini. Gak apa-apa. We count on you Pak for the development of electrification in Indonesia. And then the next award goes to Meister Ralf Ulrich. Dankeschön, Mr. Ulrich, for giving us your experience and presentation. And last but not least, the certificate will be awarded to Mr.
Thank you very much.
Yeah. And next, Pak Ahmad, for our old buddy, Mr. Eddie Kim. Okay, he's here already from Masca to Masca. And last but not least, we'll have our KFU buddy, Mr. Dirk Snyder. Pak Snyder, when are you going back to Indonesia? Yeah. If you don't come
The plan right now is end of August.
End of August,
This year.
okay.
This year.
Okay, thank you. We'll be waiting for you. And hopefully after that we can visit
Thank you very much.
during the InnoTrans, hopefully.
That would be great.
In September, yeah.
That would be great.
Okay.
Thank
I
you
think
very much.
Those are all the certificates awarded. And now it's time for us to listen to Mr. Chairman, Pak Hermanto Diatmoko, to give the closing remarks for this webinar. Pak Hermanto, please.
Yeah, thank you very much, Pak Krishna. Distinguished Pak Alan, Director General of Railways, all the speakers, and then member of MASCA, and all other participants. We would like to after we have the seminar in this afternoons, we have the discussion about the technical point, especially for the electrification, and then also how to set up the future, the master plan, something like that. So on behalf of the MASCA, we would like to thanks to all of you, and all of the material can be sent to you after this webinar. So with we're saying Alhamdulillah Rabbil Alamin. So I obviously close the webinar today, so we can meet again in the next webinar and the next seminar, maybe in the
Thank you very much, Mr. Chairman. And I think it's going to be closing our webinar today. And thank you very much for the audience for joining us today. I think Ahmad has already taken the picture of the audience and the participants. And I hope to see you again for the next webinar. Thank you very much, especially for Pak Dirjen and all speakers to be participating in our webinar today. Thank you. Good afternoon. Assalamualaikum warahmatullahi wabarakatuh.
Salam.
Thank you,
Pak Krisna, Pak Hermanto. Thank you, everyone.
Thank you, Pak Dirjen.
Thank
Terima kasih, Pak ya.
Okay.
Sampai ketemu lagi.
Thank you to everybody.
Bye.
Bye.
Mrs. Snyder, auf Wiedersehen.
Auf Wiedersehen. Pak Krishna. See you
Thank
soon.
you. Bye-bye.
Ralf, danke dir.
Bisa Ali, hope to see you soon in Indonesia. Bye. I'm going to close this connection. Thank you very much.